In this presentation, we will discuss the present value of annuities. When discussing present value in general, we said we want to picture, and we still want to picture when considering present value of an annuity, the idea of having two time frames, now and in the future, and the choice as to whether we would rather have the money now, $100 today, versus $100 in the future. And we know that we would typically rather have the $100 today. In other words, today's value is typically worth more. If we had the money now, it would be worth more than the same dollar amount in the future. Or thought differently, if we want to have the same value to us today and in the future, the dollar amount we have today will be less than the future dollar amount. In other words, we would need to be given more money in the future to be equivalent to the less money that we would get in today's dollars. That's going to be the kind of concept, the central concept with present value and future value that we want to have in our mind. Now we want to differentiate the present value of a single sum. If we were going to present value just one number, taking a future value and bringing it back to the present value terms versus the present value of an annuity. An annuity means we're going to have a series of payments. We're going to have a series of payments, and that's going to constitute an annuity. Now, if we're considering an annuity like these $100, they would have to be an even series of payments. So if we have an even series of payments over an even interval, like yearly type of payments, then we can use an annuity formula, which is in essence just a variation on the present value type of formula. So we could do one of two things if we had an annuity in this fashion in order to present value it. One, we can use the old method we have and use and basically present value each year out. So if this represented 3 years of $100, we can present value each one of these years and then add them together using our present value formulas. Or we can use another technique, which would be an annuity calculation, and use an annuity formula in order to get to our calculation. So in other words, if we took our present value formula, we can basically add together these three payments and say we have the present value of period 1, period 2, and period 3, and add those together. So in essence, we're saying if we're going to get $100 a year from now, 2 years from now, 3 years from now, we're just going to apply the present value to each of those years, bringing all of those years back to the current dollar amount, the present value, and that's going to be one format that we can use to calculate this. And this is going to be useful with capital budgeting, capital projects, because we're going to have cash flows out into the future, and we're going to want to pull them back into the same basic dollar amount, the same time frame, today's dollars, the time at which we're going to make the decision. So in this example, if the rate was 10% and we had the $100, then we can add this into our formula, the 100 over 1 plus 0.1 to the 1, 100 over 1 plus 0.1 to the 2, 100 over 1 plus 0.1 to the 3, and we get to the present value of 248.69. So that's going to be kind of around what we should expect, because note that if we have the cash flow of 100 times 3, you would expect it to be 300 if there were no time value of money involved. If these are the three payments and we want to bring them back to the current time period, and we want to measure them in today's dollars, then you would expect it to be something under the $300 amount. It's common to get a little bit confused about the present value versus the future value. So note, when we were thinking about the present value, it's useful to have a scenario, a common setting that we would put this in context in. In other words, if we were thinking about the future value, we might be thinking, oh, these are going to be investments we put in $100 each time period. We're trying to think about what the future value would be at the end of that time period. That's not what we're doing here. It might be best to think of an investment type of project that we're putting money in, $100 in year 1, $100 in year 2, and $100 in year 3. And what we want to do is decide whether or not we want to do that in the current time period. So we're trying to make those payments, although they don't all happen in today's dollars, so that we can make the decision as to whether it's going to be a good idea or not. So when we think about the present value, it's often useful, as we will be doing with capital projects, to think of these outlays possibly as expenditures. We're making a payment in the future, payment in the future, payment in the future. We're going to pull them back to the current day and think about it in that fashion. Or you can think about this as income in the future, income in the future, income in the future, that we want to pull back to the current day and compare to an original investment that we're going to be investing at this point in time, as opposed to a future value scenario where we would think about us investing in something like stocks and bonds or something like that, typically, where we would say we put $100 in, it's going to earn $100 in, it's going to earn and grow $100 in, it's going to earn and grow, and then get to the future value amount, the amount that we expect to have in future dollars at that time point period, at the end of the time period. So our present value of an annuity formula is going to look like this. It's going to be a bit more complex here, of course. And for this reason, in practice, we don't typically use the present value of an annuity formula. We're going to use Excel, or we're going to use a financial calculator. Even in schools, they don't typically require you to fill out the formula or use the formula too much, because in practice, it's a lot more useful to know the concept and then use the tools, which usually includes Excel. So this is going to be the formula that you may have to use, and it's good to have an idea of it and know of it, so that when you do see the formula in terms of presentations such as this, we can understand what it is and what it is in relation to the same types of calculations that can be done in other ways, including the tables, which are often used in schools, because that allows us to use a simple calculator without having other kind of functions that they may not want in tests, and still do it in a similar fashion as we might do in practice. And then, of course, in practice, we would probably use Excel, would be the way that we would use this most often, and that's the way that you probably want to get most familiar with for practice. But again, you want to be able to see all of these different formats and be able to know these aren't different animals, these aren't different things, these are all the same things, and you can prove that to yourself by solving them in different formats. And then when you see them in different ways, they're not something that's going to be intimidating. You're just saying, oh, they did that with a fancy formula. I know what it means. I know how to do that. I can do it with a table. I can do it with Excel and get to the same numbers, the same concepts. So here's going to be the table, which we often use. So there's 3 ways to do it. We've looked at a formula, and then typically in schools, we're going to use these tables because that allows us to do how we would typically in practice and not have to use the formula. We're not concentrating on math in terms of math for math's sake. We're looking at application, and the tables help us to do that. So remember, there's 4 tables usually. We're looking at present value tables. This one, we want present value of an annuity. So anytime we have multiple payments that are the same, we may be able to apply the present value of an annuity. We've got the rates up top. We've got the periods on the left-hand side. So we're going to be picking then the 10% and the 3 time periods. So that's 2.4869. And note what we have here is something that we would kind of expect to have, right? Because we're talking about 3 periods. 3 periods, if we had $100 was our amount, times 3, you would think it would be times 3, you'd have $300, because we're putting $100 in every year for 3 years. So in this case, it's got to be something that's lower than 3, but above 1, clearly, because we're talking about something that's going to have to be less than $300 to present value it, discounting it at this 10%. We'll also talk more about this 10% and where do we get to this 10% in future presentations. That's going to be our discount at this point in time. So it'll be given now. We'll discuss where that comes from a bit more in depth in a later presentation. So if we want to take a look at that, then we're saying the $100 times the 2.4869 that we got from the table, and that'll give us our 248.69, same idea that we would get with a formula. And this is the way we would most likely see it probably in schools and testing type of situations. Now, the most useful way to do it in practice will typically be Excel. And we really want to know the present value of an annuity, present value of one. They're really the same functions. They just are used a little bit differently, which is nice for us to be able just to learn that one item. So we're going to go into formulas. We're going to go into the function library group, and then we're going to insert function. This will help us to search the function if we don't know it, or if we want to use the formula box to help us to enter it more easily. We can type in present value. We're looking for the PV, which was the same present value as a present value for one formula. We use the same function for the present value of an annuity, which is nice. So once we know the difference, how to calculate them both, we can use the same PV function, and that could save us some memory space on that. So we're going to say the rate is going to be the first thing we need. The rate is in cell B4. So we have B4. Rate is 10%. So 10% given here. And then we have the number of periods. That's in cell B2. The number of periods, we're saying years in this case, which will be 3. So B2, we have 3 years. And then we have the payment amount. Now, last time we didn't use the payment amount because we weren't doing an annuity. We were present valuing 1. We put a 0 here, and then we used the future value. If we were present valuing 1 item, that's what we do. We put a 0, and then we go down here. But the payments are there for an annuity. This is an annuity. We're going to be making payments. The payments mean that we'll be making a payment each of these 3 years. In this case, 3 years, $100. We're going to make it 3 $100 payments, $300 in total. So we've got the 100 in B3. It'll give us the answer. It's going to be in a negative, unless we put a negative somewhere, 248.68. So there's our answer, 248.68, rounded to 248.69. And then if we see this in basically our format in terms of just a function, if we could just type it into Excel, we'd say equals. I usually put a negative in front of the PV to flip the sign. So that'll flip it from a negative result to a positive. Present value, and then we'll go through our little dialog box. We've got the rate first. That's in B4. So in B4, we have the rate 10%. Then we have the number of periods. So the number of periods is going to be B2. So then we have B2, and that of course is 3. And then we have the payments, and the payments is going to be B3. So we have B3, and that of course is the $100. And so that's the same thing as we did on the prior slide. Now, in just terms of a function, it's a little bit easier to enter this way. This is what will be in the cell if we were to use this dialog box as well. Remember that we can use the same present value function. Now, we can use the same function for the present value of an annuity, and then if we need to look for some other factor within that formula, we can use the goal seek feature. So for example, if we had this data up top, if we knew the number of periods, if we knew the payments, but we didn't know the rate, and we knew what the present value should be, then we could basically say to Excel, I want to use the present value formula here, use the present value formula to find what the rate would be. So we'll basically enter the formula here, and then we'll use goal seek and say, hey, tell us what the rate is based on the present value formula here. And we'll say, hey, Excel, make this number be what it should be by changing this cell. And again, we could do the same thing down here for the periods. If that was the unknown, we could use goal seek to find this. We'll do this in our Excel example problems. If you'd like to work through this using goal seek, we'll say, hey, here's the present value. We know the 10%. We know the payments are 100. We're going to enter the formula for the present value here, and then ask Excel, would you please make this be what it should be? Because we know the answer, but we want to use it in a formula by changing the periods. And then it'll change the periods in order to find the correct answer, which will be 3 in this case. The point here is just to say that we can use the same present value formula then to have the same dialog box for a present value of an annuity, and then we can not have to memorize 2 other functions if we know everything except the period and we know everything except the rate, because we can use the same present value function and goal seek to find them. That's one way that we can find those items, all with the same use of the same function within Excel, which is nice.